So welcome everyone again, and let's start with this SDXS fundamental course. And this is your first session, and in this session, we are going to discuss these two main key topics of Cisco SDXS and Cisco DNS Center introduction, right? So these total topics you can see on the PPT. So SDXS solution components, wireless architecture, how you can do the network changes with the help of automation. What is the fabric? How you can deploy the fabric within the DNS center, and what are the key use case of assurance, and how you can leverage DNS center as a platform by using different kind of APIs, and you can configure it with the help of different adapters. So today we are going to discuss these two main topics: SDXS and DNS center introduction, right? And I'm not monitoring the chat, but if you guys are having any questions, please feel free to unmute your self and ask questions. I'm trying to give all the possible answers here only. And in case if I need to search something, then definitely I'll get back to you. Okay, so let's start. Before anyone is doing any questions?
Give the recording permission, sir.
What?
The recording permission, so that we can record from our end.
Actually, I'm recording, but I will share the recording with you after the class.
Right? Hi guys. Sorry to interrupt you. That's Sushil here. Okay, guys, can you hear me?
Yes, sir.
Yes. Okay. By trailer, that class will be recorded. Individual recording will not be given as
well. Okay. Thank you. Thank you.
Yeah.
Thanks, Sushil.
Yeah. Listen.
Okay, so let's start, guys. Let me give a brief introduction of DNS Center. So in this particular topic, we are going to conduct a couple of networking principles, which Cisco is using to implement new intent-based networking on the campus infrastructure. What are the key deployment models of DNS Center? Because DNS Center has different versions and different scale factors. And based on that, we need to implement DNS Center in our topology. So we are going to discuss that as well today. Then SDXS overview. What is SDXS? What is Fabric? What are the key components, and then the DNS Center graphical user interface. So for that, we are waiting for the lab. Once our lab is ready, I'll show you and I'll walk you through the lab, and will help you to understand what are the key pillars and how you can navigate across the different tabs. So in traditional network, right, like we have core, distribution, and access. So this is the kind of topology which we used to have in traditional enterprise infrastructure. And it is more focused on the hardware part. So it is hardware centric, where we need to configure each and every hardware manually. We need to go box by box, log into the device, take the CLI, and do the configuration. And any software change, anything you can do through the device by device or hop by hop basis. And everything is manual. And whenever it is manual, it leads to the error prone network configuration and network configuration and changes, right? So that is the most challenging thing, I would say, in traditional network, and the fragmented security. Because if you are implementing any of the policy-based infrastructure network, then you need to, anyone has any question? Okay. Yeah. So in traditional network, like if you see, we used to have those type of access list and policies, which we implement and configure on the hop by hop basis. And due to that, our TKMs are increasing, and the ever growing demand of new users, bring your own device concepts, makes this particular traditional network irrelevant in some sense. So Cisco has introduced intent-based networking technology, and it has the specific controller-based architecture, where your controller is DNS Center appliance. And with the help of a single appliance, you can manage your all of the network infrastructure, all of your network devices. And this is not just only management purpose. You can do a much more than that, much more than management. We are going to discuss that in the later course, right? So those are the traditional network challenges you can see, and we need to overcome, and we need to solve those challenges with the help of this newly intent-based networking portfolio. So far, so good. Any questions? We will try to make this section more interactive. And if you have any questions, feel free to ask. Okay.
Sir, Um, Hi, sir, Rashmi here.
Yeah, Rashmi, go ahead.
Can you please explain this fragmented in their security part? How security is impacted if we are having manual infrastructure or traditional infrastructure?
Sure. So, like, see, if you want to implement any of the access list, access policy, right? So you are implementing those access list, access policy on the device by device. And suppose most of the time, network engineers what do? They keep on adding network access list, and they may forget some of the network access list to remove based on the different scenario. And that list of the SELs are keep on increasing, and that leads to increasing the PCAM size. And due to that, like some of the device has some of the access list, some of the device has not some of the access list. And due to, you can find that it is fragmented on the security aspect. So probably identical configuration may not be found if you are going with the manual approach. And if an employee is doing any of the network security related changes on any of the device, and if that employee is leaving that organization, then next employee who is handling the network infrastructure, they may not well aware about the specific access list, because those access lists are based on the IP address, like source IP and destination IP. And it may difficult to identify an identical configuration, make them identical configuration, right? So that is the meaning of fragmented security. So we're going to see the use case, how we can get rid of that particular challenge.
Okay, sir. Thanks.
So Siddharth, another doubt. Like here, see, when we have three different controllers, like orchestration plane and management plane and control plane, data plane, like 4 planes actually. So like in DN access, we don't have that many planes, like just one DNX center only, which control everything. It controls basically.
Yeah. So you are referring to SD-WAN, I guess. So in SD-WAN, you have your orchestration, your data management and control. Here only, we have 3 major plane, like your control plane, data plane, and policy plane. So the policy plane is important when we talk about security, because ICE is the critical component when you are talking about SD access. So we are going to discuss that as well in later slide or in upcoming sessions.
Yeah, but sure. But for all those planes in SD-WAN, we have each separate device. Like for orchestration, there is a B-bone.
Yeah.
Yes. But here, I think we have only DNX center only, right?
Correct. So for this SD access, you have a DNS center as a brain, and it will do all the orchestration. It will get the business intent from the user or network engineer on its GUI. And by taking the business intent, it will try to implement that business policies, business configuration, whatever the policy compliance with that organization, it will try to implement to the network device. So yeah, there is a single pane of glass, which is your DNS center, but some of the device role may change. So in traditional network, your access, distribution, and core would be the same. But here in SDXS, that device role would be changed, like control plane node, border node, and edge node. So we are going to discuss that as well.
Sure. It's in that course stage.
Correct. Cool. So as I say, DNS center is the control, central piece, or I would say orchestration device, where it is a single pane of glass where all of your devices are onboarded. And with this particular controller, you can use the design, policy, provision, and assurance. So these are the 4 main pillars, I would say. And there is one pillar as well, which is called your platform. That we will discuss that in upcoming slide. But yeah, these 4 pillars are the main pillars when we talk about DNS center. So why we need that? What is the purpose to have a single pane of glass or this type of controller? Anyone has any idea?
Just to simplify it and access it centrally.
Correct. It is the key catch, I would say, to simplify. Because day by day, our network is increasing, our applications and our users are more demanding, and new concepts like BYOD, work from home, and remote branch offices are increasing day by day, and our network is increasing in a rapid way. So to monitor, to maintain, to automate, to onboard such devices, and to manage those devices, we need some sort of tool, or I would say some sort of controller. So DNS Center is a hardware-centric appliance It is based on UCS series server, and it comes with another model which we will discuss in upcoming slide. But yeah, that is a physical box you can use inside your data center or inside your network infrastructure, and it gives the single pane of glass, which is your GUI. With the help of that GUI, you can take the end-to-end health information of your network devices in the real time. So when I say in the real time, that means like one of your router goes down, or one of your switch goes down, or suppose one of your access point is not working as proper. So you can get the insight. And suppose one of the specific user is not able to access specific application, right? So how you can troubleshoot it? So in traditional network, we generally start with the ping, reachability, routing and switching, basic troubleshooting things, right? So same thing you can do in DNS center. But here the concept is we need to get rid of the CLI and we are more focused on the GUI. So everything you can do from the GUI itself. And in DNS center, there are a couple of tools which you can leverage to utilize those troubleshooting steps. And it also do some sort of remediation and guided based assurance, right? So those are the things, those are the key points, I would say. Another important topic is like automation. So most of the time when we want to do some sort of automation, so automation is a very big term, I would say. So in network engineering field, when we say automation, we can do some sort of configuration on the device automatically with the help of any script. We can do onboarding of those devices with the help of some script. We can provision any of the device, right, with the help of some tool or script or whatever, like Ansible, Python, most of the network engineers are using nowadays. But here in DNS Center, everything can be automated with the help of this GUI, where you need to create a kind of workflow. There is a specific workflow to automate the device. So suppose you have a couple of devices which are coming, or which those devices are going to come to your network infrastructure, right? So most of the time in traditional network, what happens? Racking, stacking, cabling, and then any field engineer go to site, and then it connects the device. Then a vanilla template or basic reachability template, that particular engineer copy from the USB to that device, and then your device get connected and get onboarded on the network. That is the standard procedure. Generally, most of the traditional network has. But in DNS Center, it is totally zero touch. When I say
okay, if you are saying that we can do ping and trace route from the DNAC, do you compare that to NetBrain? It is a tool to use the network monitor and found the network environment. Like if you are giving IP address, it will trace the route, or it will give some graphical views of the network. Is it like that, or it is?
So correct. The same thing, you can get information like graphically. Like when you do some sort of trace route, you will see your traffic is moving from one hop to other hop to other hop, and that hop is also located. It has the specific location, like your access point is located on any of the floor, and your user is behind that particular access point, and you're trying to trace the specific application, right, which is behind your data center. Then a trace route application inside DNS Center will show the complete path, including the physical location of the device or nodes. Apart from that, ping. So yeah, ping is a normal thing. And in troubleshooting, in assurance, you have that option where you can see the reachability, and also it has the option of guided remediation. So it gives you that level of insight when any of the interface goes down or any of the server is not reachable. It starts giving you the command like, do this, do run show IP OSPF, do run show IP EIGRP, do this, do that. So most of the time you don't need to worry much on the troubleshooting workflow. Rather than you can focus on much more productive work. So that is the main I would say about this technology.
Okay.
So as we are discussing about the automation. So when I say zero touch, that means it is completely automation thing where your new device can be onboarded on the network inventory, or I would say on the DNS Center, zero touch. So we will discuss that. We have two options, plug and play and ZTP. But ZTP is more focused on the SD-WAN side. Here in SDXS, we are using plug and play, and plug and play protocol is a unique protocol. So that is one thing. Then policy enforcement. So when you identify a specific user, like you have so many users and users category, right? Like your guest users, your contractors, your employee, your HR team, your finance team. So many users and so many roles. So each and every user has different set of policy. So to implement that policy, it is giving you the kind of construct where you can create the policy for specific user rather than specific IP. So the main idea is like identity-based segmentation and policy enforcement. So we will focus more on the identity of user, like who is that user, rather than specific IP address. So that is the other part. And for analytics, right, as I said, assurance is the key piece. So in assurance, we have a couple of dashboards where we can see the client health. When I say client health, that means your wired and wireless traffic or endpoints, like your wired endpoints as well as wireless endpoints. Then network health, that means your network devices, including your routers, switches, access point. You can get the health related insight, troubleshooting related steps, and all the context where you can get to resolve those issues, and even some sort of alert as well, right? Then application. So most of the time we may see that whenever any application is not working, or if any layer 1 team or any basic support team calls network layer 3 team that, hey, this application is not working, then most of the time we try to check with the reachability, and all. If reachability is good, then we can just directly shift to the that particular issue to the application team. Then application team will check its own code and the server hosting thing. But here in assurance, we are getting that application level insight where any application is not working, or due to some QoS, it is not giving the proper throughput or proper customer experience, right? Then you can identify those type of issues. So assurance is a very important use case within the DNS center. And last, which is your platform. So last use case is platform. So that is the key pillar, I would say, when you want to integrate, because Cisco has the idea to make this particular appliance as an open source. So whenever you want to do any sort of integration with DNS center, like suppose you want to do some sort of ITSM tool integrated with DNS center, right? Like your ServiceNow. So suppose you have a kind of requirement where I would say you can create a kind of workflow where any device which needs to be upgrade in upcoming days, you can create a ticket in ServiceNow. That ticket goes to the CAB review, where your peers or network architect review the specific change, and based on the maintenance downtime, it will approve they will approve the specific change request in ITSM ServiceNow. And that ServiceNow is integrated with DNS Center. So as and when your change requests get approved or your maintenance requests get approved, your ServiceNow can talk to DNS Center, and the particular workflow will kick off, and then the SWIM will start initiating the upgrade process. So SWIM is the software image management inside the DNS Center. So you can use that particular tool to upgrade your device image. So this is one of the example for platform, but you can have many more integration with your third-party network devices or third-party tool, like your dashboard or other sort of database you want to see. You can integrate that with platform while creating the API and software developer kit SDK, right? Am I going too fast, too slow? Is it okay?
That's perfect. Fine.
Okay, good. So when I say a network admin, this guy is implementing any of the intent. When I say intent, means any of the configuration, any of the policy that is called intent, that is aligned and complies with your business policy, your company policy, right? So this particular network admin wants to implement anything on your network, then that intent goes to the DNS center. DNS center will translate that intent and it will implement the specific requirement, whatever mentioned by the network engineer, to the specific network devices, whether it is your wireless controller, router, switches, server, whatever. And once it is implementing, it will also share the contextual information to the DNS center. So DNS center is doing two things. One, it is implementing all the network changes, all the network intent on your devices, whatever defined by your network engineer. And second, it will also share its data, its telemetry to the DNS center. So DNS center will analyze that data and it will represent a graphical information and different dashboard, where based on that you can identify where is the issue and for which hop you need to do some sort of troubleshooting. So that is the kind of loop which DNS center has. When I say loop, that is not routing loop or switching loop, but yeah, this is a kind of cycle you can see. The intent goes to the network devices, and context, your information like your syslog, netflow, other traps are going to DNS center. It analyze that information and it will give the graphical representation. Second. Yeah. So DNS center has 4-step workflow. You can see. So your design, provision, policy, and assurance. So when I say automation, so automation falls under this 3 category: your design, provision, policy, and assurance is a separate piece, because in DNS center we have 2 main platforms. One is your NCP, which is your network control platform. Second one is NDP, which is your network data platform. So NDP will manage your assurance related information because it is directly related with data and all the logs, all the event triggers from the network devices to the DNS center. And NCP, which is your network control platform, falls under this automation. So under automation, we have these 3 main tabs like design, provision, and policy. So basic requirement for DNS center to have is like you should have a kind of design where you can define your site hierarchy. Like your site would be like San Jose, then the global site would be California or US, suppose, right? Under US, you have your San Jose as a site. Under San Jose, you have different buildings or different area. And under area, you have different building. Under building, you have different floors. Likewise, you can create the hierarchy, site hierarchy. It is really important to have this planning in place when you are first provision or creating the DNS center fabric, or I would say setting up the DNS center. Then your global settings. So global settings means like your AAA server, your DHCP server, your XNMP servers, your NetFlow servers, so many things you can, like your time related NTP. So those falls under global settings. When I say site profile, so site profile generally has generally covered the wireless related aspects like your RF profile settings or frequency, signal to noise, some of the RF related settings and all. And your other than site profile, we have this SWIM, plug and play, and DDI. So we are going to discuss that in upcoming sessions. But yeah, on high level, I would say that this is the design where first you need to create the hierarchy, site hierarchy. You need to import your floor map if you are placing any of the access point on the floor to check whether that access point is spreading proper RF or not. Or even there is a specific integration in DNS center where you can do. And once you're done with that integration, you can see the live user which is roaming from one floor to another floor. You can see it's moving on the floor easily on the DNS center. But that integration will not cover in this course because that is another topic, I would say, which is your DNS space. That is another controller, I would say, which generally integrate with this DNS center. Now, design is okay. So once you're done with design, you need to provision. So first, you need to onboard the device. So most of the time, what happens? Either customer or company has existing device which are compatible with DNS center, right? Or customer or company has new device which are compatible with DNS center. You can onboard. So there are 2 types of things. So for existing device, you can directly onboard that device with the help of discovery. So there is a tool within DNS Center. You can use that tool. You just need to have the reachability from your device to DNS Center. That's all. Once reachability is done, it will use, your DNS Center will use the level 15 privilege to logging into the device. It will create the SNMP string. It will create some of the device controllability settings, and then it will onboard the device on the inventory. So that is a first step. Second is like your new device, your greenfield devices. So for that, you can use a plug and play. So plug and play is another topic. We'll deep into that, but on high level, these are the things which falls under the provision. Once your device gets onboarded, you can create the fabric, you can do host onboarding, and so many things. And the third one is policy. So in policy, you can create the virtual network, your ICE, radius, and AAA, your TACAX settings you can create. Your access list, all the access list you can create from the DNS Center itself. You don't need to go to ICE or any of the AAA server. You just need to go to the policy tab here, and you can see here the diagram is very small, but yeah, there is a policy section. Under that, you can find all the access control and application control information, and you can create the virtual network. So virtual network means VRF. So you can create the VRF, and based on that, you can segment your network traffic. Last not the least, assurance. So as I said, assurance would be used to give the insight like issues and trends, ongoing issues and trends. And performance related KPIs are also measured in the assurance, and proactive troubleshooting. So as I said, proactive means like whenever any fault may find or found on any of the network device or client or any of the thing, it gives the notification. It also gives the mailer alert if you have configured that. And it also provides the guided remediation. And in some aspect, it also do the proactive troubleshooting.
Sir, Govind here. In today traditional network, hub and spoke locations. In spoke is my office, which is talking to my data center, communicating through MPLS network. So the same way this DNS center will work. So DNS center is I placed in my data center, and my hub location, I am putting some devices which communicate to the DNS center through the MPLS network.
Correct. Yeah. So yeah, good question. So the idea, like we need to follow the latency requirement. So if you are creating hub and spoke tunnel, MPLS tunnel from suppose India to London or India to Australia, then the latency may not meet. So to create the kind of fabric, you should have the latency requirement adjust or met to the standards, Cisco standards, and then only then you can create the fabric. So I would say whenever you are creating any of the fabric or any of the site, you can use DNS center and you can put that DNS center in data center, and the minimum latency requirement should match. Based on the matching, you can create the fabric and then start onboard your networking. Yeah.
So only the Cisco device I can use on my office locations, right? In the DNS solution.
So that is again good question. So I would say I would like to give answering different way. So when I say Cisco devices, so most of the Cisco devices will be managed, provision, automation, and assurance can be done on the Cisco device. Or you can say your DNS center can get all the insight from Cisco device to the DNS center. But when you are using any of the third-party device, suppose Juniper or HP or whatever, like your other device like Arista, then that device can be seen on the inventory as a part of the workflow or inventory management. You can also do the software upgrade of different vendor devices based on the compatibility matrix. But you cannot do everything. Like whatever you do for Cisco device, you can't do everything on the other boxes. So that is the answer.
Thank you, sir.
Can we integrate API with this DNS center for that third-party devices?
Absolutely. So for that, you need to write your own code for that. and we have so many APIs which are already available in DNS Center, and you can go on developer.cisco.com where you can also find lots of APIs are getting created every day by our developers and developer community, right? So based on customers' requirement or specific individual requirement, anyone can write their own API and call the API to DNS Center, and it will work. Correct. So we discussed this, like your DNS Center dashboard, which has this design, policy, provision, and assurance. And the DNS Center appliance is the physical appliance. You can use the virtual appliance as well, like any of the UCS server you can bought, and based on that you can install the virtual image. But on most of the production network, this is not the ideal way, and this is not the best way, which Cisco is not recommending that thing, because it gives the scale issues and other issues. Some of the use case may not work, some of the things may not work on soft images, because the DNS Center image is very heavy image, I would say, and all of the services are containerized. So each and every service has different set of container, and that container is based on the Linux maglev config platform. So whenever I say SNMP service or your assurance service, your NetFlow service, or your any of the service, right? DNS Center has lots of service. Each and every service has different set of containers, and different containers are communicating with each other inside DNS Center. So in DNS Center, we have used this Docker Kubernetes, and we have kept different types of container for different services, and those containers are integrating and communicating with each other with a specific IP. So we need to give the IP address of each and every container, and each and every container is communicating with each other container as based on the need with the IP address. So we'll discuss that. What are those two IP address, and those are subnets, how you can check, how you can implement when installing or bootstrapping your DNS Center. But this is how internal things work actually. And the appliance is like your telemetry storage. So any of the contextual data, which I said, like your SNMP, Syslog, NetFlow. Suppose you want to ensure that your DNS Center appliance is also acting as a NetFlow server or Syslog server, and you can just check the box, and your DNS Center will act as NetFlow or Syslog servers as well. So it will hold your data, your NetFlow and Syslog data for 14 days, and then it get updated every 14 days, every after 14 days, right? And if you want historical data, then you can integrate DNS Center with the platform to external NetFlow server, or you can directly integrate external NetFlow server or Syslog server, so your data can transfer to that third party. And network devices and physical and virtual. So yeah, we discussed that as well, like network telemetry, contextual data, and application visibility. So network telemetry means your device related information. Contextual data means like your any of the Syslog or NetFlow or any of the traps which you have configured on network devices may convert it into the contextual view. And application visibility, like any of the application, your Skype is not working, your WebEx is giving latency, your customer is complaining that my website is not working. So you can troubleshoot that as well. So let's double click on the scaling factor, I would say, because we need to focus that when we are trying to implement or bootstrapping the DNS Center. So this is your appliance, and this comes with 3 form factors based on the UCS M5 series server. So when I say 3 form factor, that means 3 different models, but the functionality of those models remains same, and those device has the preloaded image. So it has image already installed, so you don't need to install anything on new device, DNS Center. So 3 models are like this: 44 core, 56 core, and 112 core. It is based on the scaling and number of endpoints and how big your network is. Based on that, you can choose the DNS Center appliance. So for big enterprise, most of the company go with the Excel version. So for medium and large, I would say appliance, company, they go with the 56 core, and small company, they go generally with 44 core. The functionality will remain same, but the scaling factor will change because the number of user this particular DNS center will hosting will low compared to XL version.
Yeah, quick question. If I have like a 44 core server, can I implement, can I, like virtualize that in a EXXI server?
Yeah.
Is it possible?
Yes, it is possible. It is possible. But when I say like it is possible, you can use for your lab testing or that type of version. As of now, Cisco has not come up with this in production. Like most of the customer are using hardware appliance, which is based on the MCS UCS M5 series hardware. So
Okay.
yeah, you can use for your testing and lab purpose, but yeah, ideally it is not recommended.
Okay, just for the lab purpose. Okay.
Correct. So the scaling factor decide based on this criteria, like your number of client counts, whether it is wired or wireless count, then your resource requirement, like your CPU or input-output throughput, or I would say bound. Based on that, you can identify and check the compatibility and adjust your requirement, and you can go with the specific version or specific model. And based on the resources, like number of sites, number of applications, number of VM. So that gives you the idea to decide which version or which model you can implement in your company. So this is the original photo of a DN1 appliance. This is the back side. You can see the interface and cabling, right? So there are a couple of ports mentioned, like first is your cloud port, second is your management port, third one is your CIMC port, fourth one is your enterprise port, and fifth one is cluster port. When I say cloud port, so just one second. Yeah. So cloud port is your 10 Gbps, or I would say a specific port inside DNS center. And this port is used for redundancy purpose. So generally, you can implement DNS center as a standalone box, or you can use the cluster. So in cluster, you can use 3-node cluster for high availability purpose. So when you are going with the 3-node cluster architecture, you are using this cloud port to interconnect other DNS center so that your with any natural calamity or any disaster, if any of the DNS center goes down, your secondary DNS center will become active in high availability situation. So this port will be used for cluster purpose. Then enterprise port. So this is again 10 Gbps port, right? So this is again 10 Gbps. So cloud port is 1 Gbps. Sorry, I missed and say 10 Gbps, but yeah, it is 1 Gbps. We have 10 Gbps 2 ports only, enterprise and cluster for DN1 appliance. So we have two appliance, two version, DN1 appliance and DN2 appliance. DN2 appliance is more improved version, I would say. The ASIC and other things are improved in DN2, and some of the port name is also changed. But this name, not cloud port, management port, CIMC, this name will remain same. But the specific enterprise name, like ENP1S, ENP1S0, F0, that name has changed for DN1 and DN2 appliance, right? So we are talking about DN1 appliance. So yeah, we have discussed this cloud port for cluster related thing. Then enterprise port. This is your 10 Gbps port, you can see, and that is for your network adapter 4. So this port is used to discover your devices. And with the help of this port, your DNS center will connect to your devices. So whatever you are configuring or whatever you are applying any of the policy, right, that will go to network devices via this port only. So this is the main port where your all of your network devices are communicating to DNS center via this port. And also the telemetry information. So when DNS center fetches the details about SNMP or syslog, the telemetry information is also goes to this enterprise port. And another port is like CIMC port. So this is your CIMC port. This port is used for console access of the UCS box. So when you want to do power off, power on remotely, you can use that CIMC port. You can plug in and you can give the IP address, which is accessible inside your network intranet. And you can use CIMC to launch the KVM. And under KVM, you can use the power on, power off, and do kind of cold restart and hot restart of the physical appliance. Or even if you want to access the CLI of DNS Center, suppose, maglev wizard of DNS Center, then you can also go with this port only.
Actually, CMC is basically like BIOS settings, correct? BIOS upgrade or something.
Correct. So it gives this box console. So it gives the GUI of this UCS box, and on that UCS box, you can check fan setting, power setting, so many things. And you have that this particular maglev wizard where you can launch the KVM and you can access the CLI of DNS Center. So there are two ways to access CLI of DNS Center. Either you can SSH the DNS Center IP address with specific port of 2222, or you can log into CIMC IP address. You can start the KVM and then you can access the CLI.
Actually, as per the Cisco, that CMC port is used to access the BIOS settings. Only it won't give the command prompt of the DNAC. There is
Yeah, but here in this case, you need to launch the KVM, and once you launch the KVM, you can get the access of CLI.
Yeah, CLI of that BIOS settings only. So you can monitor that fan speed and disk space and everything. You can set it up. But
yeah, that is, you can monitor with the GUI. But when we launch the KVM, I'll show you. I have a slide. I'll show you how you can check the.
But CMC port, SIMC port, we cannot do the function of DNAC application like controlling the device, controlling the other network device or something like that. That CMC is purely purpose of the only BIOS and the device on the hardware.
No. When I say you can log into the DNS Center CLI, that doesn't mean that you are controlling the network devices through the CIMC port. No. The meaning of that is like you are accessing the maglev wizard of DNS Center on which your DNS Center image software has installed. So you can do any of the Linux-based troubleshooting or any of the container-based troubleshooting when you want to do of DNS Center. So you have your network device CLI, right? That is another component. And you have DNS Center CLI. So when I say DNS Center CLI, that means a kind of maglev wizard where you can access the wizard and you can log into the maglev platform. And on that platform, you can do troubleshooting on Linux. The code is accessible, not every line of code, but the command line is accessible to CIMC of DNS Center, not network devices. Now, we have the management port. So whenever you want out-of-belt management, so for that purpose, you can use management port. So most of the time, customer may use that port and it is highly recommended. But some of the customer, if they don't want to use the management port and they want to access GUI of DNS Center with enterprise port only, they don't want out-of-belt management, then they can go with that option as well. It is optional. And cloud connectivity, cloud port. So cloud port is also important. Sorry, that we have discussed, right? Yeah. Okay. So so for cloud port, I say this is for internet connection. So for swim use case and other use case, you can use the cloud port, and it is highly recommended because all of your iOS versions, patches, and information getting downloaded from Cisco.com through internet connections, and that internet connection get terminated on the cloud port. And the cluster port, as I said, that is used for inter-cluster communication for your 3-node cluster from one DNAC to other DNAC and that DNAC to other DNAC. That's how it gets connected. Anyone has any doubt on this port-related information, cabling related? Okay. So how you can do the cabling? So this is how you can do. So this is DN2 appliance. See, this is DN2. Some of the name has changed. So previously, let me go to the site. Cluster port name start with ENP10S0. Here, the name is this ENP94S0F1. Right? But the purpose of this port is same. It is cluster port and it solves the functionality of connecting one DNAC to other DNAC for the case of high availability. The same like that enterprise port, the functionality remains the same. The name has changed, right? Now, when you are doing any sort of HA cluster, high availability, then you can do this type of connections. Like for cluster, you have one switch, right? For enterprise, you have one switch, and for management, you have one switch. and this switch are uniquely given. I mean, this switch has different VLAN, or I would say different subnet. Based on that, you can identify this subnet is different, this subnet is different, and all. That's why we have different color code. So I said earlier, right? Like DNS Center has kind of container and pipelines, and it is based on the Kubernetes. So each and every container has different service running on, and that service has specific requirement. So the requirement is IP address, because suppose my one service wants to communicate to other service, then how it will communicate? However, it is inside the image or inside the Linux platform. But then also, if you have ever come across the Docker kind of thing where you are having different types of services in different container, and you want to use those services simultaneously, then you need to give the IP address. Same like that, here you have this cluster service subnet and services subnet. Those two subnets will be used internally to provide the IP address of the containers which are available in DNS Center to make sure that your all services are running properly. So for that, you need to give the cluster service subnet and services subnet IP address, and your cluster IP address as well, which is required. Enterprise IP port, as I said, that is used for your communication to your network devices. That is also required. And your gateway for management or enterprise. Suppose if you are using only enterprise port, then you need to give the gateway IP address of that. If you are using management port for out of band, you need to give that as a default gateway. So these are the main subnets or IP addressing which you need to give. And for cluster and services subnet, you need to keep in mind that /21 subnet you need to give, or less than that, like /19, 20, 18, 15, 16, whatever. But maximum minimum is /21 you can use, because there are so many services. So many IP address may required. And some of the important IP addresses, your DNS server IP address and NTP server IP address. So these two are reachable. It should be reachable. Then only then your DNS Center installation can work properly, right? And when you are connecting your cloud port to internet, these are the links. These are the proxy links, or I would say port links, port details, or specific site which needs to be allowed if you are using proxy. So if you are using internet via proxy, suppose you have firewall, and after firewall you have the internet connection, right? Then on firewall you need to allow this particular website and this domains to pass through the connection to Cisco.com and some of the smart licensing related website internally to Cisco. So this is the maglev configuration wizard. When you launch the KVM on CIMC, once you log into CIMC, you have an option to launch the maglev configuration wizard. Once you log into that, you can start. You can see this particular screen as well. But this is the initial screen. When you bootstrap the DNS Center and gets the console of DNS Center, you will see this screen, right? But you can also see this screen using the CIMC as well. So you can go with this, start a DNS Center cluster. And suppose you have already installed the DNS Center, and if any of the new DNS Center would like to join the cluster with existing DNS Center, then you can select the second option. Need to give some of the IP addressing, like the cluster virtual IP addresses. So that is the virtual IP address, which will be useful for your high availability, your Linux password, your CLI password, and some of the administrator paraphrase, that is also password. And once you're done with the IP address configuration, you will see this type of message: configuration succeeded. So that is how the maglev configuration can work. Now we are going to discuss the high availability part. So in high availability section, you can see we have 3 nodes available, right? And all of the 3 nodes has different same services because it is identical. So here you have service A, service A, service A. You have service B, F. So these services are different. But why it is different? Because some of the services are running on this particular node. Some of the services are running on this particular node. Some of the services are running on this particular node. In case of any service related issues. So generally what happens is like identical one node would be active. So all of the service will work on the same node, and it gives the information to DNS Center contextual engine, and you can see the services are up and running or not. And if in case of any service goes down, suppose services goes down, then the cluster of another node, like the standby, will become active for that service only, right? So service A from node 2 will become active, and it will give the it will solve the purpose of the automation or assurance. Suppose entire node goes down, then again your node 2 will become active and node 3 will become standby. Like
So what about the service B and C? What are the services that that is going to affect it?
that are examples, service A, B, C, D, that are example. That is not the actual name.
Okay.
There are so many services. When we have the lab ready, I can show the service as well. So all that questions in that time. Yeah.
So we can even distribute a load among the cluster members.
Ideally no, because whenever the node 1 is active, that means all the service will run through this node only. But in case any of the service goes down, then your node 2 will become active for that service only. That is how the architecture is. But you can't do that thing like I run 5 service on this node, 5 service on this node. That can't work.
Okay.
So this we have discussed earlier, like in design, we need to set up site, building and floor. You need to organize your region, city, building. Then you need to import your floor plans. So there is a specific format of floor plans. You can get it from DNS Center design dashboard. And then based on that criteria, you need to import your floor maps on the site hierarchy. And you can place the devices as per the floor plan. Then site specific settings, like some of the settings are global level settings and some of the settings are site specific settings. So many times we have seen that many of the customer has different DHCP server for specific site. So for that, they can use site specific setting, but some of the settings like TACAX or radius, those are the global settings. So it may inherit to all the sites once you create the global setting. Then IP addresses and or IPAM. So you can create the IP address information. You can create different types of pool manually. And even if you don't want to do that pool creation manually, then you can use IPAM, which is IP Service Address Manager. And in IP Service Address Manager, you can create or import the IP addresses pools, and that particular pools will import via API to DNS Center. So once you have IPAM integration, you can see your existing IP address pool to DNS Center, or else you can do manual IP address pool creation. Then fourth one is your setting up the wireless SSID, where you can manage your wireless fabric SSID. So how you want to manage a fabric or site, that's how you can create the fabric wireless SSID IP pool. You can associate that because most of the time we have seen in true wireless fabric deployment, most of the SSIDs are fabric enabled SSIDs, but many customers are using hybrid model as well. So in hybrid, some of the wireless traffic goes with the legacy way, and some of the wireless traffic goes with the fabric enabled way. So for that, you have the specific choice. You can map and create the SSID. And automation, like automate the setup. Yeah, like how you can onboard the WLC, how you can onboard PFP. Once you discover the WLC, you can onboard PFP. So there is a specific workflow. When we reach to wireless section, we can discuss that much more in detail. All right. So for policy, as I said, for policy, you can create the virtual network. This is for your reference, like which we have generally discussed earlier. But for reference, I'm just keep telling you that this is the thing. You can see setting up the virtual network, setting up the scalable group. I'll talk deep about this scalable group, but this is the way. First, let's complete this. So manage the group policy and manage the VN policy. So scalable group. So first with virtual network. So virtual network is your VRF. So in SDXS, we have the concept of macro and micro segmentation. So when I say macro segmentation, that is by default VRF based segmentation. So in traditional network, we used to do VRF. We create different VRF, and different VRF cannot talk to each other unless we do the route linking, right? The same like here, we have this VN, virtual network. We need to create VN to segregate the traffic. That is called your macro segmentation. And scalable group, those are the identity containers. So when I say identity containers, that means like you have guest user, you have HR user, you have contractor, you have finance team, and everything falls under the employee VRF. Suppose you have created employee as a big umbrella, a big VRF. Under that employee, you have different roles of employee, like contractor, guest. Suppose guest is another thing, contractor and other team, like finance, HR, and marketing or sales and other team. How you can do some sort of policy enforcement. So you can generally get the IP address, see the IP address, create the policy, permit, deny, and all. But here we have this scalable group, which generally referred to as a identity container. Like when I say a contractor, when contractor log in to my network, it has the specific identity. So SDA or ICE will provide the specific tag, like this contractor has, this particular user is fall under the contractor scalable group, and that contractor scalable group has the specific number, like suppose 70 or 80. So it tagged with this particular number. So whenever or wherever that user is go or roam, the tag will always carry. So based on the tagging, you can do the segregation or classification of the user in SDA. So that's how a scalable group will create, or you can import those from ICE if you have ICE deployed already. And you can do so many things under policy, like managing group policy. So this is the kind of segmentation based on the scalable group tags, like permit, deny. Suppose you want to have the type of policy where employee, like normal employee, cannot talk to the contractor, or contractor cannot talk to the HR or finance team or sales team, right? So likewise, you can create that type of policy, and you can manage those policy under this section as well. So provision, we discussed that as well earlier. So in provision, you can create the fabric domains. You can assign the device and device role. Like some of the device are known as border device, some of the device are known as edge device, and some of the device, or I would say one of the device or two of the device, generally known as a control device, control plane device, right? So you can assign and create the specific role of those devices. You can create the fabric. When I say fabric, we'll discuss later what is the fabric and what are the roles. But yeah, this is the falls under provision. So I'm just taking the reference here. So you can clear, like when we come again on fabric and device, so you can recollect, okay, I saw or I heard fabric under provision. So that's how. Set up host onboarding. So this is also important for wireless and wired traffic. Your host onboarding section will be used, and it will map the specific IP pool for specific users, like wired versus wireless. It also gives the authentication templates. So we have so many templates, I would say 4 templates, closed authentication, open authentication, no authentication, and there is another as well. I forgot the name, but I'll show you when we have the library. So those templates can be used when when you want to make sure that how my host will onboard on my network. So if any company has implemented a no authentication template, then initially that host gets the IP address and access to the network infrastructure without any authentication. But if any company has implemented closed authentication, then host gets authenticated based on his or her credential. That particular person can be authenticated, and once successful authentication done, it can get, he can get the access of the network, right? And platform, under provision, there is an advanced setting of multicast to enable. So when any enterprise has specific requirement of multicast or any of the streaming, then they can enable the multicast in the fabric domain. We are not going to discuss how multicast work in fabric domain because that is not the part of this course. But yeah, multicast is the another advanced use case which generally available and most of the users or company are using this multicast as well inside the SDXS fabric. For assurance, like as I said, we have different types of dashboards and we have different types of name like device 360, client 360 and application 360. The 360 means you can get all the insight of the specific thing. Like device 360 means all the insight related to devices, your network, switches, routers, everything. Client means your wired and wireless traffic. And application means your any of the real-time applications on which you have implemented the N-bar2 license on the devices. For DNS Center as a platform, so this is really interesting, I would say, because if you know, we have a couple of APIs already created inside DNS Center. So I mentioned path trace, right? Earlier, I guess someone has asked question, how can we do the path trace and what was the outcome when we do the path trace in the DNS Center. So path trace is an API which already been there inside DNS Center. You can leverage that API and that is falls under the northbound API. So you can see we have for north, south, east and west, right? So we have different adapters on east and west side where you can have cross-domain integration. Like if you want to integrate your Stealth Watch or your DNS spaces or your Cisco Meraki solution, you can do with the adapters. And if you want to integrate some of the ITSM tools like Infoblox or your ServiceNow, then you can use that. Your IP address management, you can also use that. For Bluecat and proxy server, you can use to integrate it with adapters. So we have that adapters available under platform. You can leverage that platform and you can integrate that particular solution within the DNS Center. Then intent API, that means your assurance works on API, path trace, command runner, template, anything. Like you can see here, we have so many things, same software image management. Everything is isolated and every container has different API and the API is communicating with each other. Okay. So for third party as well, you need to create any of the software developer kits and you can use those kits to leverage to patch the device inventory data or topology data or any of the device related data. So I'll show you that when we come to the platform section, how you can do that generally. So far, we are good with DNS Center overview, everyone?
Yes, sir.
Okay. So let's have a 5-minute pause.
Yeah. Sorry.
Anyone? Yeah.
I have some few basic questions. Is that okay to ask you?
Yeah, please go ahead.
Yeah. This DNS Center, it's a kind of network centralized controller which can be used for management and inventory and automation, right?
Correct.
Is that going to reduce any existing network device? I hope no, right? So we will be keeping this to manage our network and do the automation, correct?
Yeah, I mean, definitely. So
you see,
go ahead.
yeah, if we have a DNS Center in our enterprise, let's say, we don't need any of the NMS software or let's say even the Stealth Watch, right? As far as my understanding.
So that completely depends on company's requirement.
Yeah, because the DNS Center can cover the functions of the Stealth Watch as well as the NMS and the inventory tools.
No, Stealth Watch is different. Cisco Stealth Watch is different tool, and that is purely for security and threat analytics related things. DNS Center is not providing that level of security information, like any of the threat or any of the attacks or cyber attacks are going or any of the malware available on your network device. That information Cisco DNS Center will not provide. So for that, if you have Cisco Stealth Watch, you can integrate Stealth Watch with DNS Center, and DNS Center can give you the comprehensive view, and you can fetch the detail on holistic way from the platform as a report under template. Yeah.
Okay. So in that case, the DNS Center, does it have a consolidated reports of our floor map devices? Like,
correct.
devices has the access details, these things, right?
Yeah. So
And does it act as a backup node? Let's say we have our floor map. Some of our devices, the network devices, are failing the configuration. So can we restore it using the DNS center?
some of I missed your question. Can you please repeat?
Yeah, let's say we uploaded our floor map in DNS center. Okay,
Mhm.
our network is in DNS center now. DNS center we can control using our network with DNS center. With this situation, okay, some of our network device, let's say our configuration is lost.
Correct.
Can we use DNS center to restore the configuration because it's already uploaded in the DNS center, right?
Correct. So there is a specific compliance tab under provision, I would say. So in which you can find the past configuration. And suppose like we encourage everyone to do all the configuration changes through GUI and DNS center itself. But suppose anyone, any of the network engineer has some made some change on any of the network device and it got lost, right? So you can identify the configuration drift, like what was changed, which line of configuration get changed.
So basically, it has the revisioning details.
Yes.
All the revisioning.
But,
we can go
but,
back to the.
but it has the specific limit to store the configuration, right? So and each and every component has the limit. We cannot store unlimited data on any of the box. So there is a specific limit. After that, it will not store. Then you need to have the backup storage server so that storage server can fetch all the historical configuration. Rest, your configuration will get changed with some few days, I would say.
Okay. So in that case, the Cisco DNA center is intended to do the control and automation only, not for the backups or inventory.
Yeah. Absolutely. So inventory management can be done in DNS.
No, my basic question.
Not like
sorry. My basic question. I'm just trying to understand. And which are the functionality of the enterprise segment we can use the DNS center. Backups, inventories, and reports, monitoring, control,
report monitoring, assurance, then
exactly.
On this part, like segmentation policy, creating SDXS fabric, checking your endpoints, like whether it is IoT, your normal endpoint or what. You can track that endpoint as well. Some of the endpoints are not normal endpoint, like some of the endpoints are silent host. So that host can wait on the specific packet that is called magic packet. So for that, you can use SDXS or DNS center and all. So many things. But generally, you are right. The main use case is automation, assurance, and policy and segmentation. There's three main use cases. And easy to manage your network, like easy to upgrade, easy to monitor and all.
Okay. Fine. This is what I want to understand. Thank you.
Yeah. Now, so guys, let's have 5 minutes of break. The time is now 12:23. So we'll meet after 5 minutes or 3 minutes. So 12:27. Okay. Or 12:28.
Okay.
So now we are going to discuss some of the concepts around SDXS, and for that, let me just reach my slide. So when we talk about SDXS, that is your software-defined access, and that is based on the that is based on your DNS center appliance, and that is the new technology which we generally use to automate the fabric. So when I say fabric, that is your underlay and overlay. So when I say underlay, means your core, distribution, and access are connected. You can see your access and distribution are connected. Distribution core is connected. And when any network engineer is doing any of the network changes or configuration, it is manual and CLI based, right? With SDXS, we can have this automated, and everything which falls under SDXS will convert into the fabric. So we'll discuss fabric, what is fabric and all. So this is the physical topology. You can see your server, your distribution switches, your core devices that are connected. And on top of that, you can see your overlay topology. So the same topology, But on overlay, you are using a different logical topology. The physical topology is different. The logical topology is different. When I say logical topology, that means any tunneled architecture. So whether it is your GRE or IPsec or MPLS or Lisp or VXLAN, right? So whenever you are creating any sort of tunneled architecture on top of your physical network topology, that overlay network will be called as a fabric, right? So fabric is the combination of your underlay and overlay. So mostly overlay topologies are created on top of the physical topology, and those overlay topology will be used through different overlay protocols like IPsec, GRE, whatever I just mentioned, right? So that is the fabric. So here on overlay topology, you are doing the encapsulation and decapsulation, because whenever you are creating any of the tunneled architecture, the encapsulation will start. You are adding the new header, and on the far end side, you are removing the newly added header. That's how it works. And there is a specific requirement to implement SDXs within your network infrastructure, because it has too many encapsulation and decapsulation flows. So 9100 jumbo MTU is required to have SDXs working, right? So you can see the different nodes are just mere traffic forwarder. So that nodes are just forward the traffic back and forth, but that particular nodes are not part of the fabric. Fabric consists of the device which generally do encapsulation and decapsulation. So any device who do encapsulation and decapsulation, that device will be part of the fabric. So the idea is, like, you can see a user behind this VPN adapter, it is using the private IP. So whenever we are using VPN, and you must have seen a couple of times, like whenever we are connecting to VPN, we are using company's intranet network, the private IP addressing scheme, or the confidential IP addressing scheme of that company or intranet, right? So this is because, like, we are doing the encapsulation and decapsulation. We are just hiding our IP, and on top of that, we are adding the new IP header. And irrespective of any of the nodes, any of the BGP AS, we are just creating the tunnel from your home to HQ. Now in SDXs, the main use case of SDXs is you can leverage this macro and micro segmentation and policy-based identity and segmentation. So I told you earlier that macro falls under the VRF, and micro falls under the segmentation. Within VRF, if you want to do any sort of permit and deny actions, then it comes with this micro segmentation. So for that, you can assign the SGT to specific users, and that user will be acting as per the policy which you have implemented. So same like here in this diagram, you can see we have group 1, group 2, and we have virtual network of employees, and we have virtual network of IoT, right? And we have group 3 and group 4. So in group 3, we have 2 bulbs. Group 4, we have 1 IP phone and one of the meeting console, right? Here in group 1, we have 1 laptop, and group 2, we have another laptop with user. So whenever any user wants to communicate to other user or other thing, it will start encapsulation of the traffic, because in SDXs, you are using the VXLAN as a encapsulation protocol, as a data plane protocol, right? Why VXLAN? There is a big story behind that. I'll tell you. There is a specific use case, and native VXLAN header, if you check on any of the RFC or any of the document, it is different. And in Cisco's SDXs, it is different, because we have tweaked the header, and we are using this specific header of VXLAN, specific version of VXLAN, which is called your GPO header, your group policy object header in VXLAN. And in that header, there is a specific field of your SGT and VR. So whenever any fabric edge or any of the access node is creating the tunnel, suppose from A to B, so it has the capacity, the VXLAN header has the capacity to carry the group tags, scalable group tags across different access nodes. And the use case would very unique, I would say, because based on that header, we can implement and enforce the policy that this user cannot be communicate to this user and likewise. So we'll see the header part as well. So data plane encapsulation, you can see the VXLAN header. So this is the 50 byte of overhead you can consider on the original IP packet. So that's why we required 9100 of MTU across the fabric nodes. So when I say fabric nodes, that means each and every device who will be part of the encapsulation and decapsulation process. So that device are the fabric nodes. And all the fabric nodes should have Jumbo MTU frame supported. Now, you have your original data payload, then your original IP header, then original Ethernet, your layer 2 frame, right? And on top of that, you have your VXLAN header. In VXLAN header, we have that VRF and SGT related information, which it carries from one fabric node to another fabric node. And on top of that, VXLAN header is encapsulated with this UDP transport header 4789 is the protocol, port number, and then another IP header. So this is how the frame looks like, or packet looks like, you can see. And based on that, you can identify so much encapsulation, decapsulation happens for each and every traffic, right? So that's why 9100 is mandatory within Fabric. Now, let's discuss some of the key components of SD access. So you can see we have SD access, or I would say we have DNS Center. And in DNS Center, we have policy, automation, and analytics. When I say analytics, that is the part of your assurance. Automation, that is the part of your all the provisioning related things. And policy, that is the part of your ICE related. ICE is the critical component in SD access. Without ICE, Cisco ICE, you cannot have this SD access. So SD access, you can create the fabric, but you cannot leverage this policy and identity-based segmentation. So previously, when this SD access launched in earlier version, it was mandatory that you should have your ICE to be integrated with DNS Center. And now we have that flexibility. Suppose any customer don't want to leverage this important use case of identity-based policy and segmentation, then they can get rid of the ICE and they can have this fabric, right? But there is no meaning without ICE, because this use case is really important, which decouples your security and QoS related requirement from your VLAN and IP addresses. So we are actually moving from IP addressing identification to the actual name related identification. So IoT network or employee network, we can easily identify which user get assigned to which place, right? And if a user is moving, suppose one floor to other floor, one office to other office, suppose in one fabric, you have a couple of buildings, right? And user is moving from one building to other building to floor, other floor and all. Then also the identity will always stick to that user. So you don't need to change the IP address or access list on each and every hops. So initially someone has asked fragmented security question, right? So in fragmented security, what happens for roaming related issues, like on one edge node, you have done some manual configuration, some access list. And if user is moving to one building to other building, on that gateway node, the access list is not mentioned or some of the thing is mismatched, then the security may breach. So that type of breaches we have seen, but in SD access, the user has the specific tag carried, and whenever he goes, and the tag will carry, because each and every fabric edge node has the specific Anycast gateway. So we don't need to really change the gateway as well. In manual network, we need to think, okay, for this user, we have specific VLAN and the gateway may change, right? But here in SD access, we are using the Anycast gateway. So for user mobility, it is seamless, whether it is wired or wireless. The main use case is like automated network fabric, where you can create the fabric within the DNS center. Everything is automated. Some of the configuration you need to do it manually, because out of the fabric configuration, whatever the fabric, out of the fabric configuration, like the connection to your data center, connection to your internet, right? Connection to your DMZ zone, that connection, you need to do it manually. Rest, everything is automated inside the fabric. For identity-based policy segmentation, we have discussed a lot. Insight and telemetry. So yeah, so whenever any challenge we may face related with the user or client experience or performance related thing, we can get the insight on the DNS center under application behavior or user behavior, right? If suppose user is complaining that, hey, you're going to building number 1 and I'm getting a good connection, good internet speed and everything is good. But when I go to building number 2, I'm not getting that much level of speed or that much level of satisfaction. So that level of insight, you can get it on DNS center. You can easily identify what is the behavior when the user was on building number 1 and what was the behavior when the user was on building number 2, right? So again, the same story like the traditional network, inconsistent configuration, manual, error prone. In DNS Center SDXS solution, we are using the business intent, implement that intent using the automation feature and the telemetry, which is coming from the network device back to the DNS Center, and DNS Center will give you the graphical representation. But here you can see the new 2 points are added. One is border and one is control plane, right? These two new point name has added. So we will discuss more on these two because as of now, it is really impossible to discuss in few minutes because it is really deep, the functionality of border and control plane now, how it works, what is the purpose, and how the packet is going to border, how the packet is going to the control plane, or what type of query is going and all. But you can just remember or just mention so that next time whenever we meet, you can know that, okay, we have seen somewhere border or control plane. ICE. So ICE is the critical component when you want to leverage the policy and segmentation. And it gets integrated with DNS Center with PX Grid integration. So in ICE should be compatible with DNS Center version. And we have kind of RESTful API and PX Grid integration, which we generally do when we want to integrate ICE to DNS Center. So whatever the business or policy related information you create on DNS Center, that get pushed to ICE, and ICE then later on push to the Fabric edge nodes. So DNS Center will not push any of the ICE related or security related information on Fabric edge nodes. Rather, ICE will push everything on the Fabric edge node. But whatever you are doing on DNS Center that goes to ICE will push to the Fabric nodes. That is how the flow is. So based on the authentication, so I'll walk you through the flow, traffic flow, when a device gets connected, how the packet goes to ICE, what type of packet goes, and how ICE is going to assign the VLAN or HTTP. But on high level, for now, you can understand that whenever any endpoint gets connected on the Fabric edge node or Fabric device, after successful authentication, that particular endpoint or user get assigned to the specific HTTP, right? So initially I told that we are just get rid of the IP addressing and we are now moving towards the identity-based solution. So group 1, user 1 falls under this employee virtual network, and we have the specific HTTP like 17, right? So that user has the specific tag. Now that user goes from one building to other building, the tag will always there for this particular user. Like the connection is there and the tag will always there. Once that user gets disconnected, the tag will remove. Now within the VRF, if we want to have any specific sort of access denied combination, then another user within the same identity container can have the same tag. Like for under employee virtual network, we have contractor. So if both are contractor, then you can assign both to 17 tag. But suppose one is contractor and one is HR, then you cannot assign both to the 17 tag, right? So that tag may vary under different VMs. And that tag you don't need to assign. ICE will, you don't need to worry on that. ICE will automatically assign to the specific device. But you can do your intent configuration, or I would say make the DNS center aware that, okay, whenever guest or any of the contractor comes, please assign to contractor HTTP. And whenever any user with HR credential comes, then please assign to HR SGT. So based on that, it will convert the intent into configuration. It will acknowledge to ICE, and ICE will push the configuration. Now, you can see Fabric Edge node, the node on which the encapsulation happens. That means the VXLAN tunnel creates. So it provides the first hop services and the exit, like whenever any user wants to exit from the Fabric, because Fabric generally means like you have your internal network, right? That means your Fabric. You are the part of Fabric. But when user wants to communicate to internet, then it has to go via border, and border has the capacity to forward the traffic to the internet or out of the organization. And we have control plane. So that is the separate role and separate device. Or you can use border as a control plane as well. Like you can assign both role to one device as well based on the device model and scale vector. But the functionality will change. So that's why the role of device is important. Initially in DNS center, we discussed we need to assign the role of border, access node, edge node, right? So role of device is important when you are creating the Fabric. Okay. Yeah. So this is related with WLC now. So you have the WLC, and that will outside of Fabric. You can see the cloud, whatever the cloud is there, that is your Fabric. Whatever outside is there, that is your out of Fabric device. So WLC will remain outside. It will remain outside, and then also it provides the Fabric enabled SSID. How like the Fabric is connected to, WLC is connected to the border, and border has this capacity to exchange their Fabric information to WLC back and forth, and WLC will forward the information to border. How it is going to forward, how the packet flow, we are going to discuss in upcoming sessions. But on high level, you can see this is the placement, and most of the customer may place WLC near to the Fabric border, or wherever the Fabric edge nodes are there. It has the latency requirement, specific latency requirement. So if WLC is far from your data center or from other side, then it must need to fulfill the latency requirement. So here in this slide, you can see my WLC is on data center, right? But then my latency requirement is this. Minimum 20 ms of latency should match from the access point or user to the WLC. And then only then it provides the Fabric enabled SSID. And then your wired and wireless traffic would be identical in the data plane side. Control plane flow would remain changed, but the data plane will remain the same. And then you can implement the policy on wired as well as wireless traffic in irrespective of the connection.
Excuse me. Sorry, did you mean minimum latency requirement or maximum?
Yeah, minimum 20 milliseconds.
So, like, do we have requirements like we want like minimum there should be 20 ms latency, or like maximum 20 ms is fine?
No. Minimum at least 20 ms.
So is it like nowadays we are designing network based on we should have at least 100 ms latency requirement.
100 ms latency requirement.
And like the lesser is always better, right?
Correct.
So we have maximum latency requirement, no? Like we can have only up to 20 ms. More than 20 ms is not good. So in that case, then the network flow. You said minimum, so I'm a bit confused there.
Oh, sorry for that. But yeah, I mean that is 20 milliseconds. So
So that will be
20. If it is less than 20 ms, then it is good, but not more than 20 ms.
Okay, right. And one more thing. When you said we place the WLC near the fabric edge, do you mean like controller or like wireless transmitters will place it near the fabric edge?
A WLC should always place near to border or your control plane node or your data center. Suppose you have your
Like
data center.
I'm referring like sorry, let me clear myself. Suppose when we say that we are placing WLC, so basically it's a wireless then control plane device, right?
Correct.
Yeah. So I think when you say we place it near endpoints, so those are like wireless antennas or wireless transmitters, right?
No. We need to place it near border, not endpoints, because endpoints are associated with access point, right? So access point will create a kind of cap tunnel to the WLC,
right,
for control plane traffic.
Right.
And
Your data plane traffic also cap web, no?
Sorry?
Even data plane traffic is also transferred to cap web.
No. In SDXS, the data plane traffic will go via VXLAN. That is the catch. That is the catch in SDXS specifically for wireless. If you go with traditional OTT, over the top wireless deployment, then your control and data plane, both the traffic goes via CAPWeb. But here in SDXS for specific fabric enabled SSIDs, your control plane traffic goes via CAPWeb channel.
And that is done.
Yeah. Any questions?
That's it. I'm just ordered to.
Dash, can you finish that last one you were trying to mention, right? The CAPWAS is going via control plane. The other one, can you complete that?
Yeah. So other traffic, the data plane traffic will go via VXLAN. Why? Because in VXLAN, we are using the specific header, which we generally, which I just showed you, right? Which carries the SGT and VN information. And due to that only, we are providing users to seamless policy-based identity and segmentation, whether it is wireless or wired traffic. So any user gets connected on any of the access point, right? Based on the authentication, it also gets assigned to specific SGT tag, identity container, and the specific VN, that means virtual network. Now, suppose that user wants to communicate to other user, but policy is not allowing. So how we can know that this is how we can enforce that type of use case? So for that, VXLAN is only the thing. Whatever we are using for wired, the same thing we are using for wireless for data plane traffic. But we will dig deep into the wireless traffic flow when we go to the packet forwarding mechanism and all. But on high level, we are good actually.
Yeah, thanks.
So this border and control plane we are placing at DC only, right?
No. Border and control plane will be in the fabric side only. So if you have the DC, but you are creating the campus, all the fabric edge needs to be connected to the intermediate. Suppose you have this type of network, right? Like core distribution access. And on core, suppose you have one border and one control plane node. So everything will part of the same fabric. So you need to maintain minimum latency requirement. Unless and until it is meeting the requirement, then we are good. Whether irrespective of place, data center or where.
Okay, sir. Good.
Now, let's see this component and roles. So is just I wanted to show this core distribution and access. So distribution generally are the traffic forwarders, or most of the time it do L2 spanning tree related things. But here in SDXS, it is just traffic forwarder. It just read out the traffic from back and forth to border and control plane node from fabric edge node, right? So these nodes are not part of the fabric. So whenever you may get asked that type of question, suppose like you have some of the traffic forwarders or intermediate nodes. So the intermediate nodes will be not part of the fabric. So please keep in mind. Now, let's get some high-level info on the control plane, data plane, and policy plane. So control plane here, we are using Lisp. Why we are using Lisp? I'll tell you. Because in Lisp, suppose we have so many routing protocols. You also learn so many routing protocols like OSPF, EIGRP, ISIS, so many things, right? But why we chose Lisp on SDXS, in SDXS or control plane? Because we want to get rid of that model where each and every router has the identical data, each and every router wants to push updates, each and every router wants to maintain the same routing table, same information and all. Here, we have created a kind of setup, like specifically in Lisp, there is a mechanism where one of the device is acting as a map server, and that same device can be acting as a map resolver based on the capacity, right? And that map server, map resolver terminology has changed in SDXs as a control plane. Now, you must have learned about DNS, how DNS works, right? So DNS works based on the request. Like any user wants to get the IP address against the specific name. Like it is, we generally ask the DNS server that I want to reach to this particular website. Please provide me the IP address. That is how DNS works generally. The same thing here in SDXs on control plane, specifically map server, map resolver, or control plane node, right? Acting as a centralized server, which has all the information. When I say all the information, that means it knows the topology, it knows which node is connected where, it knows, it has the table of host tracking database. So whenever any new device gets onboarded on the network, right, it always first register itself to the control plane. It says that, hey, I am this device, please note down my IP address this, and I am behind this fabric edge node. So here you can see this is control plane node. Here I have my fabric edge node. When I say fabric edge node, that means your access device, which do generally encapsulation and decapsulation, right? And this device is the first point of contact of any of the user. Same like this, right? These are also the fabric edge node. But suppose consider that there is a one user attached after this particular node. Then this is the fabric edge node. Suppose here there is a user connect here or here. Then this is the fabric edge node. Whenever any user gets connected, then that node is fabric edge node. So when any user gets connected, the fabric edge will register that user to the control plane. It tells control plane that I have one user with this IP address behind my back or behind my connection, right? So control plane has the entry that, okay, user 1111 is connected behind this fabric edge node. So it has the entry. So 1111 connected to suppose 10, 10, 10, 10, behind 10, 10, 10, 10. So that is how the mapping will look like on the control plane node. So that's how it maintains the database. Now, any user wants to reach to that user. So it asks to control plane that, hey, I want to reach 1111. Where should I go? So control plane responds to the fabric edge that please respond to that end user that you need to go to 1111. You can go to 10, 10, 10, 10. So 10, 10, 10, 10 will be the location of the fabric edge where the host is connected. So that's how the information get exchanged via control plane node. And control plane node is the brain of SDX's fabric. That's why many of the customer is using the HA on control plane. So they can have two control plane in one fabric. So if anyone goes down, another one take the backup, and it has the exchange. It will exchange the information. But suppose in this type of scenario, if one control plane, we have one control plane and one control plane only gets down, then your existing data traffic will remain flow. So your existing, whatever the entry which has resolved so far, the traffic will exchange after some timer. So we have, I guess, 30 minutes of timer after it gets disconnected. So we will discuss this in more detail. I will show you another PPT, another diagram, another packet, everything I'll show you. But on high level, you can consider why we are using Lisp, because we don't want that type of routing update related protocols which keep on pushing the routing updates to each and every node, and each and every node has identical database, and any route goes down, it makes the update to other node. Or suppose if we are using OSPF, then it flood the router LSA and all, right? and make the SPF computation high if we are using the single area. But multiple area, it has its own complexity and challenges. But Lisp is kind of pull-based mechanism. So most of the routing protocols are push-based. It forward the updates and it fills the routing table to other network node. But here in Lisp, if you want to get some information, you need to ask. Otherwise, it will not provide. So that's how the Lisp works on control plane. Data plane, we have discussed VXLAN. Why VXLAN? Policy plane is really interesting. It is based on the Cisco TrustSec. So Cisco TrustSec is the principal protocol will be used for policy plane. And how we are actually enforcing, classifying a user. That is also very important to know. Like when any user gets connected based on the credential, how my eyes will know that this user is the contractor, this user is the guest user. And the permission, how my eyes is enforcing the permission on the fabric edge that for this user, I don't want to forward the traffic versus other user. So, like this is the campus fabric and we discussed this thing. I told you earlier, right? In my earlier slide, we have NCP, NDP. Remember? So NCP is network control platform. NDP is your network data platform. Data platform will fall under the assurance. All the assurance related thing comes here, NDP, and all the automation related thing falls here, NCP. NICE is the individual entity which will be useful for policy and segmentation. We have 2 border nodes, and most of the time, based on different device model and scale, customer are using border plus control plane. So this device only acting as a border, and this device is only acting as a control plane. Same like that. But here in this diagram, we have segregated or separate control plane node, which is connected to WLC, and that WLC also connected to the border. For fabric-enabled SSID, the connection from control plane to WLC is really important because WLC will keep adding the wireless host entry to the control plane database. How it will enter, we'll discuss that in much more detail. But just to give you on high level, this is how the flow would look like. Border would be used for internal traffic exit or external traffic exit. When I say internal traffic exit, that means you have some data center which is connected and some of the applications are running on that data center. And if any of the user wants to reach to that data center, then that border will be acting as an internal border. But suppose if any border, suppose any user want to reach to internet, right? So that border will act as an external border because it gives the internet connectivity and it has the default route. So when no one, suppose any route is not found on control plane, it will ask fabric edge to reach to border, and border will take care of the traffic. So based on the destination, it will find the destination. If it is not matching based on the specific route, then it will forward to the internet. Otherwise, for intranet prefixes, it will forward to the data center. We'll discuss much more in detail, but on high level, I hope you understood the fabric role and terminology. How, what is the border, what is the control plane, what is the fabric area, and all. This slide is talking about that only, whatever I just told. So you can see the control plane nodes map system that manage endpoint to device relationship. When I say endpoint to device relationship, that means endpoint to fabric edge relationship, right? So whenever any fabric edge gets connected to, whenever any endpoints get connected to fabric edge, it has the mapping of that information. Okay, this user is behind this fabric edge. This user is behind this fabric edge. Suppose this user is moving from one fabric edge to other fabric edge. Like if this is roaming, right? So then also this control plane has the information. It get the refreshed entry with the new registration request, and it will delete the old mapping from the database. The same thing which we discussed for fabric border nodes For external border, we are using the fabric border node or internal as well. So if one border is acting as an external and internal both, then we are calling that border as an anywhere border. And fabrication node, already. The first point of authentication, first point of contact of wired and wireless endpoints and wireless control. Okay. So here I told you earlier that we could use intermediate node based on the scale, based on the size of company or organization, right? So if we want to have reachability or port density are very less, then we can use intermediate node as well. And that are the node which generally forward the traffic. They don't know the encapsulation or nothing. They just forward the traffic, and that will not be the part of the fabric. All the blue nodes you can see are the part of the fabric, right? All right, so we are now good, and I guess we are on top of that, or I guess 12 minutes. But yeah, anyone has any doubt? So we have finished 2 sections today: Introduction to DNS Center and SDXS. The walkthrough is pending. Once the lab is ready, I'll show you the walkthrough, how you can see, check, and all.
So the lab, when we'll be ready, what day do we have to attend this?
I'll answer that. Guys, see, once our lab is ready, once the theoretical part will be ready, okay, once he's done with the theoretical part, probably after the next week, we'll have the lab sessions. Okay, in between, we are getting lab ready, okay?
Okay, so the next week, the class will be there, right? Another session will be there, or this is
The station will be there, right? So it's a part of our station, right? Lab will be included in that.
Sir, one question.
Yeah, please.
Is it Saturday, Sunday class or just Sunday class?
It's a Saturday, Sunday class.
Okay, so next week we have class on Saturday as well.
Yeah.
Same time.
That's how we have planned, right, Gus?
Correct. If any change is required, then I'll let you know in advance.
Yeah. He can update us, but it's designed for Saturday, Sunday. If any changes, then we'll update you guys. Okay?
The time will be same session?
11 a.m. Yeah, 11 a.m.
Correct.
This recording will be shared, right?
Yeah, later it will be shared.
Done.